Hi everybody, AP Stats. Welcome to a little video about how to tell if a data set is approximately normally distributed. So in the previous video, we saw what to do when we have data that's normally distributed and how much we actually know about the data set if it is approximately normally distributed. You know, we know stuff about mean, we know about percentages of the data where it is around the mean. You know, if you know one standard deviation, 68%, two standard deviations, 95%, three standard deviations, 99.7%. You know, we can use table A to figure out what all these probabilities or proportions or percentages of data are, percentile rankings, all that great stuff, but only if we know the data is approximately normally distributed. So what we're doing today is we're saying, well, okay, so if I have a data set, how can you tell? Is there an easy way to look at the data or some stuff we can do to the data to figure out if it is approximately normally distributed? And the answer is yes, there are some ways we can do that. And I'm going to look at a couple of different techniques today for us to determine if the data is approximately normal. Let's take a look here. Open up a screen share here. And, when we want to assess normality, the first thing, right, just a reminder is that, when data is approximately normal, we're able to figure out quite a bit about it. And so if I draw a quick normal curve here, okay, what we're hoping to see is that our data is approximately working like this with our mu right in the middle. And then that magic point, that inflection point that's one standard deviation away, plus sigma. And so one of the first ways that I'm going to look at to assess normality is using that rule that we talked about in the previous video. I know that within one standard deviation of the mean, what percentage of the data should be in that interval? Well, that was 68%. So when I have my data set, I'm going to look at the mean, I'm going to find the standard deviation, and I'm going to look, what does that interval look like? Okay. And then I'm going to go over two standard deviations from the mean here. Mu plus 2 sigma and mu minus 2 sigma. And I know that when I color that whole thing in green, I know that's supposed to be 95% of the data. Okay, and I'll take a look and say, okay, what does that number look like? And do we have approximately 95% of the data in that interval? Because if we do, that's a pretty good indication that's approximately normal. If we go out to 3 standard deviations, it's supposed to be 99.7%. That's almost 100%. So a lot of times what you'll see is 100% of the data lies within 3 standard deviations of the mean. And that's good because that's what we want. That's what we want to show. And if it looks like this breakdown, 68, 95, 99.7, we can say the data is probably a pretty good fit to the normal distribution. So I have a data set for us, and we're going to take a look at it here. Let me move over to that screen share here. It's the unemployment rates for all 50 states in one given month. And here they are. You can see if I scroll through, I have all 50 of them. Okay. Later on, we'll be putting this into our calculators. So I'll give you an opportunity. I'll let you know when the time to pause the video so that we can get it all and put it into the calculator. I have it all on one page that we'll look at in a second. So what I'm interested in is this data approximately normal, or is there some really obvious departure from the normality? So the first thing I need to do is figure out what the mean is. And because I'm on a nice spreadsheet program called Google Sheets, we can find the average quite easily. Okay, the average is 8.62. And I can also find the standard deviation pretty easily. It's 2.22. So what I'm going to do is figure out, okay, well, what's the first interval that I want to check? Well, it's one standard deviation above and below that median. So I'm going to take my mean. Okay, so I'm going to make a formula here, equals that mean plus that standard deviation. That's the upper boundary. That minus our standard deviation. And so I'm going to say how many data points are between 10.9 and 6.45. Well, let's see. There we go. So from 40 data point 42 down to data point 8 is between those two. So when you take a look at 42 minus 8, right, you're going to get 34. And what's 34/50ths, right? 68%, exactly, right? 34 out of 50, 68%, exactly. Okay, so let's do it again. Let's say, well, that's a pretty good sign. Now let's see what happens if we do 2 standard deviations. So again, I'm going to do a little formula. I'm going to take our mean and I'm going to add 2 times our standard deviation. That'll be the upper boundary. Okay, and then here I'm going to take our mean and subtract 2 times our standard deviation. Between 13.13 and 4.23. Well, gosh, there's one there that's below. And if I go to the end, oops, it's all but the last one. In other words, 48 out of the 50, which you got it. Okay. Oops. You know, that's 96%. That's really close to our 95%, just a little bit over by 1%. So I'm still thinking this looks pretty good. Okay, and if I go 3 standard deviations, obviously it's going to be, here we go. Well, we'll do it plus 3 times my standard deviation. My upper limit would be 15.3, which is over the biggest one. And if we do the mean minus 3 times the standard deviation, obviously we get a number that's way smaller than the lowest one. So 50 out of 50 data points, or 100%, is in that interval, which that's a really good fit, I feel like, for my data to be approximately normally distributed. 68% exactly within 1 standard deviation. Go to 2 standard deviations, it's 96%. That's pretty close, right? Off by 1%. And then at 3 standard deviations, it's 100%. We're only off by 0.3%. So yeah, so far so good. I think that that makes a really good argument that we could use the normal distribution to model the unemployment rates for the states in any given month. Okay, so that's method number 1. Check the intervals 68, 95, 99.7. And if you don't see anything that's like drastically off in those percentages, probably okay to proceed. That's not the best way to check, but it's certainly a quick way to check, especially if the data is nice and put in order. Okay. That's using the 68, 95, 99.7 rule. So let's go back to our iPad. And of course, it'll have to reshare it. So there we go. So how can I tell? Well, method number 1 is use the 68, 95, 99.7 rule. Okay. And I like that method. It's pretty basic, but it gets a pretty good indication. And if you see something really wacky, like you go 3 standard deviations out and you're at 90%, so there's 10% of the data beyond 3 standard deviations, that's a pretty good indicator that it's not normal. Okay. What else could we try? Well, we learned a little bit about density curves earlier in the week. So maybe we could check and see, does the histogram look symmetrical? Because if the histogram looks symmetrical and we have that nice peak in the middle and then it's kind of going out to the sides, well, if we were to draw a density curve over it, then yeah, I start to think maybe that would look pretty normal. I'm not going to make the histogram myself. I actually have a copy of the histogram for that data here. Oops. Let's take a look at it. And, oh, sorry. Gotta cancel that. There we go. We got to switch cameras. 1 second. All right. So now, let me a little bit of a glare in here. We have all the lights on, and I actually have a couple of students in the room right now. So that's also part of what's going on in here. And it's reversed. We get some focus there. That's what the histogram for this data looks like. And you can see the orange histogram there, guys, not the gray one. Let me move that over. So we're just looking at the orange one. And while I'm with you, I would say that's questionable as to whether or not we could call that a symmetrical histogram. I think that's probably the best description for that histogram. And so right now, as it sits, I would still say, I don't know if I would call that not normal or not. You know, I would know if I'd have any questions. I am a little concerned about this point out here, this bar that's all by himself, because you can see he's been separated from the group. So the question of if there's an outlier is a good one. Outliers are a big no-no for us. So if there was an outlier, I would definitely be concerned. But I think you can see from our previous calculations that it's still probably a pretty good fit. I don't see anything obviously taking us away from being normal. So I feel like that's a pretty good fit, and we could probably go ahead and continue with the idea that this is probably approximately normal. So there you go. Another method is to look at the histogram. And sometimes this is what histograms look like. I mean, real world histograms, they don't always look like the book ones. So it does look a little funky. But that's a good way to check as well. All right. Last method is something called the normal probability plot. So what we're going to need is the data, and I'm going to put this data into my graphing calculator to do this. The normal probability plot is a special graph. I'll put a rough idea of what it is on the iPad so you can see. But the idea is pretty simple. Okay. Make a normal probability plot. And what that is, it's a graph, it's a scatter plot. I know you guys know what scatter plots are, you've done them before. So this one's a little bit different because what you do is the x-axis are the data values and the y-axis are the z-scores. Remember earlier this week, we talked about how to find z-scores on Monday. Well, now we're going to use the z-scores. We're going to find the z-score for every single one of the data points. Okay. And then we're going to plot that. And what we're going to look for is a nice linear pattern. Okay. If we see a nice linear pattern to this, then that means it's probably a good use of the normal distribution. If we see a curved pattern, or we see something where the data points do this, that is not a good indication for a normal. Okay, it's got to be a nice linear pattern. Okay, so like I said, a curve, no, we don't want that. Okay, what do we want? Nice linear pattern. That's a good indication of normal. So let's take a look at what the normal probability plot would look like for our data. I'm going to do it in two ways. I'm going to do it on the spreadsheet first. And then we're going to go ahead and use the calculator. And I'll give you a chance to put the data into your calculator so you can follow along. But let's go take a look at the data here. And what you know is I need the z-scores here. So what I can do, and this is kind of fun, is I can type in a formula so that I can get my z-scores. And you know the formula, okay? X minus mu divided by sigma, which is right here. And now we have our data and our z-scores. And so what we're going to do here is we're going to make a scatter chart. So I'm going to insert a chart. Well, I thought I was getting, there we go. And we're going to change this to be a scatter plot. Okay. And as you can see, that looks pretty darn linear, right? Whoa. There we go. So I have my data values here on the x-axis and my z-scores on the y-axis, and we see a nice linear look. And so that would tell me right away that this data is approximately normal, just looking at this normal probability plot. Okay, so let's see how you could do a normal probability plot using your calculator. So we need to go back over to the Elmo camera. So here we go. Now we straighten this out. So that data set there, it starts with 4.1, it goes through 14.7. That's the data set you're going to watch. So now's the time to press pause and get the data into your calculator. Go ahead and do that. All right, so now that you've got a chance to put that data into your calculator, we're going to take a look at how to make that normal probability plot on your calculator. I have my TI Inspire ready to go right here. All of your calculators can make a normal probability plot. I just am going to demonstrate it once on the TI Inspire. The rest of you, you will find it in your various graph options, and I can review those with you when we get back to class next week. So let me move the textbook here. And there's my TI Inspire. And the first thing you'll see is I have put all the data into my calculator, and I've called the list unemployment because that's what these statistics represent. And so in order to make the normal probability plot on the Inspire, I of course want to go to the home screen and add a graph. When I do that, I get the same thing we've seen many times where they're all over the place. Go down and click at the bottom and go ahead and put the unemployment data on the graph. And again, we get a nice little look at our dot plot, which could easily represent a histogram. What we're going to do now is we're going to change the plot type. So you go to a menu and go to plot type, which is number 1. And look at that. Normal probability plot is one of the options. It's pretty basic from here. We hit enter and we look and we see all those data points, and they do look pretty linear. Yeah, there's a couple of them on there that are definitely below the line down in this area here. Okay. And then of course the first one and the last one seem to be a little below the line. So those do give me a little bit of pause. But remember, when we looked at the 68, 95, 99.7 rule, and we looked at the histogram, we didn't see too much that would cause us for a lot of concern. So perhaps we would be okay here. All right, let me show you where this is located on the other 2 calculators. For those of you that are using my TI-84s, let me move the TI-84 into the frame here. What you're gonna see, I don't have the data in this calculator. I'll just show you where the normal probability plot is located. When you do the second and then the stat plot button, right over here on the left-hand side, you have all of your normal plots that you would have. Okay, plot 1, plot 2, plot 3, and plot 4. If you go into plot 1, in the graph types down here, this last graph over here, this is the normal probability plot. So when you go over there, you'll select it, and it'll say, okay, which axis will be the data and which list will it? So the data list will probably be in L1, and put the data axis as the x-axis. It should default to that, but just in case it doesn't, make sure it's set for the x-axis. That's the way we will be constructing all of our normal probability plots. Once you have that all entered, you can hit the graph button. You might have to zoom it, but you will be able to see your normal probability plot from there. if you're one of my TI-89 users, okay, so in your stats program, sorry, I thought I was in there. I apparently am not. Okay. You actually have a couple of steps to go through. So let me walk you through them very closely or slowly here. If you look across the top at your menu options, F2 says plots. So we're going to go there. Okay. And then you see choice number 2 says norm prob plot. That's the graph you want to go to. Okay. It doesn't really matter what plot number you choose. Mine's set for plot 1. If you push the right arrow, you can see all the other plots that are there. I'm just going to use plot 2 because that's what it defaulted to. Okay. Then you can see we have to put our list into list 1 or whatever list you've chosen for your data. The data axis is the x-axis. Please keep that as x-axis. Mark with a box. Store z-scores. You don't really have to worry about where that goes. And then come down and hit enter. And what it just did was define a plot. Now I have different data in the calculator. If you want to see the plot, you know, this is where it gets a little tricky for my 89 users. You can see we have the graph in green here. I'll go to the graph. Okay. The zoom will be a little funky. I've got a box whisker plot you can see there. I'm not sure what data set this is, but you can see there are some things here plotted. And so go to F2 for zoom, and then go down to number 9 for zoom stat, for zoom data. And then you'll see your normal probability plot from there. And you can see that whatever data I've got graphed here, it's got this bit of a curve to it in here. I would not want to say that that one was approximately normal without doing some more rigorous checks like the 68, 95, 99.7 rule. I'd want to look at the histogram and so forth. This one looks to be kind of skewed to me. All right. There we go. And yeah, it's the end of the day to finish up the video since all the stuff behind me now all of a sudden. So finally, just a summary here. So to finish up, I'd just like to remind us that we've looked at 3 different ways to assess whether or not a data set can be modeled using the normal distribution. Method number 1, use the 68, 95, 99.7 rule. It works really well. If the data seems to fit the proportions, I'd say probably it's going to be okay. Take a look at a histogram. Okay, make the histogram. What does it look like? Does it look like it's kind of that same bell-shaped curve that we talked about? That density curve, does it look approximately normal? Okay. Option 3, make the normal probability plot. Your calculators are very good at this. They do a nice job. The Inspire even draws the line of best fit through the z-score data values graph, and you get a real sense for if it's linear or if not. If it's not linear, definitely don't try to apply a normal approximation to it. Anyway, that's it. Thank you guys so much for hanging out. I will be back on Tuesday. So the next day's work will also be on assessing normality and starting to wrap up chapter 2. The test is not until Thursday, the 28th. So I just look at the calendar. I couldn't remember what the date was. So we will definitely have plenty of time to ask questions and get everything solidified in class. So thank you guys so much. Hope everything's going well. And I'll see you guys on Tuesday.